Okay, so welcome to the video, and so we're going to try out these three problems. Now, why we're doing it this way is because obviously you have been introduced to algebraic equations quite a number of times, and you should have a very good idea of what is expected of you to solve for x. But obviously there are different types of questions, and the way that we approach these questions is some of the techniques that you should know going into your November exams. So the first one that we're going to look at, the first three that we're going to look at is these ones. So again, since this is a video, obviously, if you obviously have a problem or maybe you want to ask more questions or want to try it out on your own first, please do that and then watch the video as you go along. So the first one is 2.4.1, so 2.4.1. And basically 2.4.1, what it has, it says it's 2x minus 3 multiplied by 2x plus 3 is equals to 0. Now remember what we actually associate this type of equation with. Usually we get to the step once we have factorized a quadratic equation where we have something like x to the power 2 plus 2x plus 1, where we would go to the last constant number and look at what we have multiplied to get that number, but also those two numbers that we use to multiply to get the constant, then it should add to give us the middle number, right? So in this case, what it basically means is that if it says 2x minus 3 and 2x plus 3, remember, it's all equals to 0. How can any two things multiply each other to give us 0? It's only if either one gives us 0, right? And how could that give us 0? So for instance, what you'd say then from this point on is just to say 2x minus 3 is equals to 0, or 2x plus 3 is equals to 0. Now, why did we do this? And why did we say or instead of and? Or meaning that it could either be 2x minus 3, whatever we get for 2x minus 3, and 2x plus 3, whatever we get for 2x plus 3, that would give us that either one could be 0. Okay, but notice, okay, then we take negative 3 onto the other side, becomes positive 3. We have 2x on this side. We divide on both sides, and once we divide on both sides, then we have x is equals to 3 over 2, right? And then also here we do the same thing, and so we take positive 3 onto the other side, becomes negative 3, and it's 2x, and we divide by 2 on both sides, and after dividing by 2 on both sides, we find that it is negative 3 over 2, right? And so these are the two answers for this equation, right? But what was I saying at the beginning? I was basically saying that it's either one of the two. So notice if we put 3 over 2 in 2x minus 3 and 2x plus 3. So when we say it is 2 times 3 over 2, and it says minus 3, this is in the first bracket, and in the second bracket it's 2 of 3 over 2 plus 3. What do you see here? This multiplies each other and cancels out. We're left with 3 minus 3. So in this bracket we actually have 0, and in this bracket we'll actually have 6, right? So it's actually 0 times 6. But 0 times 6 gives us 0, and that's why we say either of the two, right? And then let's look at 2.4.2. So 2.4.2, so 2.4.2. So 2.4.2 basically says it's 3x minus 2. It's 3x minus 2 over 7 is equals to x minus 2 over 3. Right. So this is 2x minus, I think we said 3. No, sorry, it's 3x minus 2 all over 7. That is equals to x minus 2 all divided by 3, right? So in this case we have two fractions, right? We have on one side we have 3, and on the other side we have 7, right? So how could we get rid of the fractions, right? So the idea, whenever you see a fraction, always try to get rid of the fractions. Now in this case, what you could try and find is the lowest common factor, right? The lowest common multiple, sorry. So the lowest common multiple between 7 and 3 is actually 21. So what if we multiply by 21 on this side, and we say it's 3x minus 2 over 7, and we multiply everything, and then we say it's 21, so it's x minus 2 over 3, and then what would we get? So 27 divided by 3, that would actually give us 7 times x minus 2. And also here, 21 divided by 7, that would actually give us 3, and that would be 3x minus 2. And so from there, you have brackets, so you have to multiply in. And when we multiply in, what do we get? We actually find that 3 times 3 would give us 9x. 3 times 2 is negative 6. 7, sorry, so it's 7. So it's 7 times x, that's 7x. 7 times minus 2. Now, what is 7 times 2? 7 times 2 is basically 14, but it is minus 14, right? So it's minus 14 in this case. So it's minus 14. So now we have everything as linear form in its linear form. Now the only thing we need to do is group the like terms. So it will be 9x minus 7x, and we take negative 6 and becomes positive 6, so it's minus 14 plus 6 on the side, and then we know that 9 minus 7 would actually give us 2x, so it's 2x, and we know that minus 14 plus 6 would actually give us minus 8, and that would be minus 8, and then we divide that by 2 on both sides, and we actually find that this would be minus 4, right? And that would be your final answer for that one. And so then we look at 2.4.3 and 2.4.3. So 2.4.3. So 2.4.3 is an exponential equation where we have, it says it's 27. So let me try and write this better. So this is 27 times 3x is equals to, I think it was 1. Let's see if it is 1. So yes, it is 1. So now there's actually multiple ways in which you can find this, but the easiest way by far is by actually dividing 27 from this side and the other side as well, and then on the one side, then you'll be left with 1 over 27, right? So 1 over 27, so 1 over 27, and you'll be left with 3x. But because it's an exponential equation, what do exponential equations actually require from us? It requires from us to actually have on one side a base, the same base on both sides. We need to have the same base on both sides. In this case, it is 3, so we need to find a base that is 3 to some exponent that will actually be the same as 1 over 27. So in actual fact, what you should notice is that when 3 times 3, that's 9, but 3 times 3 again, that's 27. So when we say 3 times 3 times 3, it's 27, and that is actually 3 to the power 3. But then 3 to the power 3, then as a fraction would be what? It would be actually 3 to the power negative 3. And in this case, what you should be thinking about, you should be thinking about your exponential rules. The exponential rule that was used in this case to move from here to here is the one that says that for any base of a with a negative exponent, so let me actually write it better. So for any base of a with a negative exponent can be rewritten as a fraction of that base and that exponent. So in this case, we know that 27 is the same, right? It's the same as saying that it is 1 over 3 to the power 3, but then using this exponential rule, then we can rewrite it as just the base 3, right? Base 3 and to the negative exponent 3, right? And that's what we did. Now we actually have the bases to be the same. So in this case, then the only thing we need to do, obviously, is to what? To actually kind of cancel them out and bring them down. So then we're left with x is equals to minus 3. And that's how you tackle an exponential equation. Now with these three questions, they're usually covering the three most important equations that you'll have to solve in algebraic equations. The first one has to do with quadratic equations. And as I said, at this point, they actually gave us a quadratic equation which they have actually shown us the factors. Now the only thing we needed to do was to separate those factors, and once we separated them, we wrote them out and then we got two answers for it, right? And then same thing again. Now with 2.4.2, what you should notice is that they used fractions. Now with fractions, the most important thing you need to be able to do with fractions is to get rid of the denominator, and being able to get rid of the denominator will make your solution come out quite well. So how do we do that? How did we do that? We basically looked for the lowest common multiple, and the lowest common multiple between 7 and 3 is 21. And so then we multiplied by 21, as you saw here. We multiplied by 21 on both sides, because we're multiplying everything on the left hand side and we're multiplying everything on the right hand side. And so then we are able to find that when it's 21 divided by 7 gives us 3, but 21 divided by 3 gives us 7. But there's actually another way of looking at this, if I could just show you. So if it was the same equation, and this same equation basically says this, x minus 2 all over 3. Now, another way you could have done this, let's say you did not know the lowest common multiple of this particular equation, then what you could do is you could say, okay, I have 7 and I have 3. Let's make the denominators the same. So how can we make the denominators the same? I could say it's x minus 2 all over 3, and I multiply this by 7 over 7. But also on the other side, I would say it is 3x minus 2 over 7. This is times 3 over 3. Now what did we actually do? We took the denominator of the one fraction and we multiplied it as 3 over 3 to the other fraction that has a different denominator. And then we did the same thing for 7. We took it and we put it there, and then we multiplied it with the denominator, right? And so look what happens. So what do we get? At the top we will get it's 3, and it's 3x minus 2, right? All over 21, right? 7 times 3 is 21, right? Equals to 7x minus 2 in the bracket over 21. But now since we have 21 and 21 on both sides, we can actually multiply everything by 21. So if we multiply everything by 21, multiply everything by 21 again, you see that this actually cancels each other out, right, quite easily. And then you actually left with the same thing that we had on the one side, where we would have 3 times the bracket 3x minus 2 and 7x minus 2. As you can see here, we are only going to be left with the numerators only, right? So it's the same method, same way we could do it, right? And then with the exponential equations, again, the most important thing here is definitely knowing your exponential rules. Now notice something, you could have also done it like this. So it's 27 times 3x, or that is equals to 1. But now if you know your exponential rules very well, 1 can be actually 3 to the power 0. I just made the base the same. But 27, we know this is 3 to the power 3 times 3 to the power x. But then the bases are the same. What happens when the bases are the same? That means we must add the exponents. If we add the exponents, then we would have 1 base 3x plus 3 to the power x plus 3, right? Because the bases are the same, therefore we add the exponents, and that's equals to 3 to the power 0. And remember, this is also an exponential rule where for any base to the power 0, it's equals to 1, right? And that's what I used. It's 1, so I could put any base there to the power 0 and it will still be the same thing. So from there, we have the same bases, and you can see that this would actually give us the same answer of being negative 3, right? And therefore, that is it for algebraic equations. So other than that, I hope this was helpful, and I hope you saw quite some interesting techniques that you could use in this case. Other than that, I wish you all the best, and I'll see you next time.